John Hall was a man of many parts. Born in rural Ohio in 1932, he became one of the pioneers of Silicon Valley, founding leading semiconductor companies Intersil, Micropower Systems, and Linear Integrated Systems. Before leaving us in late 2014, Hall had made numerous contributions to the world of electronics that helped millions of people. Hall was an early and prolific Silicon Valley inventor. In a career that spanned over 60 years, Hall developed technology included in over 20 fundamental patents, including pioneering work in low-power CMOS integrated circuit technology. Hall served in the U.S. Navy in the late 1950s, working with aircraft electronics development and testing, often riding in planes that were pulling target drones to collect data. He graduated from the University of Cincinnati in 1961 and sought to apply his chemical engineering education in the nascent semiconductor industry. In 1962, Hall met semiconductor pioneer Dr. John Hearne, a co-founder of Fairchild and inventor of the planar process, the basis of today's electronics industry. Hearne and Hall worked on several consulting projects together, which led Hearne to ask Hall to work for him at Union Carbide. Hall's work there included the development of the first onboard aircraft computer made entirely of integrated circuits, used for the SR-71 Blackbird. Hall worked as Union Carbide's director of IC development from 1962 to 1967, and his years there included innovations that were to lead the semiconductor industry. These include the first application of thin film technology, the first dual transistor on a single chip, and the invention of dielectric isolation technology. The Union Carbide semiconductor plant Hall built at Mountain View later became Intel's first production facility. In 1968, Hearne asked Hall to join him in the formation of a new company, Intersil. As co-founder of Intersil, Hall headed R&D and achieved a breakthrough in coating silicon oxide gates with phosphorus gas, resulting in the first practical metal oxide semiconductor process. Hall's Intersil team also developed the first N-channel memory chip at a time when most companies overlooked its potential. Hall's work in thin-film resistor and CMOS technology formed the basis of Intersil's electronic watch development for Seiko, which was chosen over a competing bid from RCA. Hall's watch was the first successful quartz crystal watch, running on a 1-volt battery that would last over a year. Following the sale of Intersil in 1968, Hall declined Hearne's offer to join him in a new venture and opted to go out on his own with the backing of Seiko. Hall went to Japan to be the principal architect of Seiko's and Japan's first CMOS fabrication facility in 1970. In 1971, Hall founded Micropower Systems, and for the next 15 years produced a string of commercial and technical successes. In one example, Hall competed with Motorola and Texas Instruments in a bid to Medtronics to create a computerized heart pacemaker. Hall's design allowed the pacemaker to operate for 10 years without a battery replacement and enabled doctors to change its settings via remote control rather than invasive surgery. In 1986, after a highly publicized technology transfer dispute with Seiko's new management, still a key investor at his company at the time, Hall was forced to leave Micropower Systems. He initiated a lawsuit against Seiko that was settled out of court in 1990. Hall in 1986 founded Linear Integrated Systems and continued to develop new IC and specialized discrete device technology. Retirement was something Hall never considered. At the time of his death, he was continuing to lead the company as chairman of the board and chief executive officer, and was continuing research into further noise reduction in junction field effect transistors. Linear Systems' continued success in the high-end audio market, medical, military, and test and measurement fields was a direct result of John Hall's commitment to excellence at the company. In a departure from his semiconductor endeavors, Hall in 1992 founded Integrated Wave Technologies, a speech recognition company that employed former Soviet scientists and engineers. As a sister company to Linear Systems, IWT successfully developed body-worn speech recognition devices for DARPA, the Air Force, the Navy, and the Department of Justice.
I want to see some more cool things.
I have something that U.S. forces are actually using over in Iraq and Afghanistan right now. This is a translator made by a company called Integrated Wave Technologies, and if I speak a command into it, a short command, it will speak back that command in a local language. In this case, Iraqi Arabic, but it could do up to, I think, 120 other languages.
These devices were highly successful in Iraq and Afghanistan operations, and IWT's work was recognized as a significant accomplishment in the book DARPA, 50 Years of Bridging the Gap.